whichever has got the highest or heaviest weight of the panel would be the heaviest lift. The highest lift is the highest panel from the ground, basically. So that would be something which is on the apex, maybe on grid line 19. So for me, the highest lift would be probably this panel over here.
Does would that include any height that's below FFL?
Yeah.
Oh, okay.
Yeah. So that's the panel.
It's not just the height from the ground, it's the overall height.
Yeah. So not only it is over the ground, it is the highest going over here. Even below the ground, you can see it is quite deep. So, and that probably would be one of the heaviest as well. If it is a 200, it's 150 PCP. Okay, it's a 150 PCP. Is there anything happening 200 on any of the?
Yeah, I think most of the 200s are shorter, even though they're thicker.
Yeah. Yep. Just see which one is the biggest 200, and then compare between the two. I think on grid line 19, you'll get the heaviest as well as highest.
Hey, RJ, have you got a couple of minutes so I can just share my screen because I'm still a little bit confused about this T plate?
Yep.
Okay, thank you. Okay, thanks. So I'm just trying to work out how I draw on this one. Yeah, I don't know how to draw on this one. Oh, here we go. Okay, so this is not working. Sorry, I'll have to find another way. I can't.
Hi, RJ, since Monique is like, figure out something, can I just ask a question about 6035?
Yeah.
For the first element is about the bulk excavation, and you told us how to do it, and bulk fill also consolidation too. And about when we're doing the concrete part, they still have additional filling on the floor slabs. Do we have any additional filling on the floor slabs?
You need to check your drawings. Is there any additional filling going under the floor slabs?
Because when we're doing the bulk excavation, I think we already filled in for the grade light 19, remember? That time we
Yeah.
just, yeah,
Yeah, because like you have been given a ground prepared, which is 350 mm below your finished floor level.
yes.
All the filling has been done basically for you.
Yeah, so for my understanding, we don't have additional filling under the floor slab.
I don't think so.
No, yeah, I just want to double check for that.
Yeah.
And also for the 2.12, we have 25 millimeter sand blinding below the concrete slab. Do we need to add this one on? Because when we're doing concrete, it's still right on 20 millimeter for the sand blinding. We have 150 millimeter hard fill.
Mm-hmm.
Oh, yeah, they do have it. Sorry, my mistake. They do have it.
Yeah.
Yeah. So yeah, I just leave it.
Mm.
And also for the roof part, we have 6.06 eaves facing and the soffit, including supporting framing. I just want to know, do we
Have
have
you got
that?
any eaves? Have you got any eaves coming out of your any soffits coming out on your eaves?
Yeah, we have eaves. So I'm just wondering, do we have like do we
there-
need to count in that one?
Is there any soffit over there?
I have,
Because your eaves are coming on your PCP panel, which is like on your grid line A and grid line D.
so let me check.
I don't think there is any eaves coming over there.
Yeah, okay, so I can just ignore it. And when we're doing actually the
There
tables,
is any soffit coming. Sorry, eaves are there. There is no soffit coming.
yeah, no soffit, no soffit. So when we're doing that, do we need to delete other elements or we can leave it in there? Then we're just doing our parts like a roof and the substructure elements.
Don't delete any element in between because you might have to calculate them later in your group.
Okay, we just keep it, right?
Yeah.
Okay. Yeah, Monique, you can keep going.
Oh, thank you. Yeah, so this is sort of how I visualize this T plate. So the maroon, this one here is the T, and then this is grid line 10. And this is grid line D. And this is that's how I see it working, but so that's not right. Are you saying that the T is out here?
My question to you, Monique, over there is, does it make any changes into your measurement and your plates measurement or anything?
Well, it does indirectly. Yeah, it does.
How does it do? Your T
Because if I
plate
can't, because I've just got to visualize what's happening. I know we're not engineers and we're
Yeah.
not welding it,
Yeah.
but in order to,
What we are measuring is your T plate is basically a metal plate.
Mm,
We're measuring for the area of T plate. Then we're measuring for the area of the cleat over there. We're measuring for the area of the stiffener plate over there.
yeah, but
Even
if this position goes here as opposed to there, then with regard to the bolts,
now tell me, if it is there, how would your stiffener fix into this thing? How would you screw the stiffener into that?
mm,
If it is right at the corner, how would your stiffener fit into the bottom to there, and how would your PFC would be screwed over there?
so okay, so to answer that, this is how I don't even know if this is just how I picture it. And then you got the bolts.
And how would you get just 2 bolts basically?
Well, no, there'd be 4. Remember, this is bird's eye view, so there's 2 there and then 2 below.
Tell me
And
how would you do it, because PCB panels will come first. Your structural steel is happening after that.
oh, I didn't know that.
That's the basic thing. PCB panels are coming first.
Okay,
Then only structural steel is happening.
right. Okay. So that's there, and then that's probably there,
That's how it should be.
right? And then all of the so there'd be an equal angle along here,
Yep.
and then the cleat, the silly thing, it goes to the hand if you get too close to the other one. And so the cleat would go there. Hang on. Yep, there. Is that right?
Yep. Cleat will connect to the PFC from the bottom, basically. So it's happening after the T,
And the PFC would be, yeah, there. I just can't draw it. There. Is that
Yep.
sort of how it goes? Yeah.
The PFC is going all the way from here to the end over here.
Mhm.
The cleat is happening at the end over here. And
I'll stop sharing.
so,
Yeah, Ajay.
yeah,
Yeah, I have few questions, but not it won't take a long time. Maybe
you think so?
5 or 10 minutes. That's all.
You think so, Chandra?
Very quick question. Already you have done it. So.
Yep.
So first of all, to adjust the concrete strength price, shall I share my screen?
Yeah, go for it.
Yeah.
Excuse me.
What is this? Yeah. Yeah. First, if I want to have a concrete detail price, so I go for the strip footing. For strip footing, they have mentioned the price, but the strength is not mentioned actually. So for this strip footing, price for what concrete strength?
You go on the top of this page, go up.
Yeah.
Rates for concrete, including ready-mix concrete, delivered to site, discount weights. So that's 20 MP.
It is not given.
Okay, concrete work. Ending of base position. All right. Now, exposed aggregate concrete. So it's not an exposed one. You go down. So there is a concrete price for 20 MPa or 25 MPa given over here. Right. Which is,
yeah, that is only delivered to site price.
Yeah. So that is delivered to site price basically.
Mm.
And then you come down and you see your unreinforced concrete prices.
Yeah, I need the reinforced price concrete.
And you go down and you got reinforced concrete price. All right.
Yeah.
Now that is 324 for a 20 MPa if I presume it right. It will not be for 25 or 30 MPa, because for 25 and 35 you have to add. You go down, there would be something.
Yeah,
telling you-
here.
Yeah,
This
so
part.
see, concrete strength 25 MPa, you have to add this much extra.
Yeah.
So that is for 20 MPa.
Yeah, this is here they have given, see, add extra for
Curing of the
concrete.
Huh.
For 25 MBA concrete,
Yeah.
the curing is 3.8. And for 30 MB, I understand it's that way,
Yeah,
20.8.
yeah.
Not for the concrete strength, this one. For add extra for curing of concrete. Yeah.
I had that question as well because Ronnie, in one of Ronnie's examples, he said he added like $3.80 to make it 25 MPa, but
It is what it is basically. Curing of the concrete is just a wording given to you. That is the cost for 25 MPa. You add $3.80 per meter cube extra. For 30 MPa, you add $20.80 per meter cube extra.
Yeah, that's what we also understand.
Yeah.
But first I need to make sure that this strip footing concrete price for the 20 MPa or something else.
This is 20 MPa. That's you
But-
know, understood, because 25 MPa is given separately to you. Like you have to add $3.80 for that.
Yeah, but it is not mentioned here in the top. It is not mentioned.
But it is mentioned at the bottom. Somewhere it is had been mentioned that for 25 MPa add this much extra, so that you have to, do a little bit of, thinking, and it's a matter of assumption basically. Straight away you can, say that, yeah, because 25 MPa is 3.8 extra, so that means this price is whatever given are 20 MPa. Yeah, because the next one up is 25 MPa, and then next one up is 30 MPa.
Yeah, I think the wording of the curing concretes are just not clear. That's all.
Yeah.
Curing doesn't cost you anything. Curing is just to leave it on the side basically to cure. You need 40
It's
days.
just a
to cure
step.
from
You,
the-
Yeah,
you
but
have to do it. You don't
Yeah.
need
But-
to. You don't need to pay any money. It's just a
Yeah.
step. You need to do it. You have to
Curing is,
put in the
curing
steps.
is like 14 days it is required to get 90% of the strength, and 28 days it gets 99% of the strength.
So, but spraying water in the 7 days and the 14 days, they need to spray water again. If water get evaporated, so
Yeah, but that wouldn't matter on the concrete strength per se. So I think just what RJ said, just add that. Yeah. And what
So
about
you
35
mean-
is my
you mean-
question.
You tell me one thing, Chandra, if it is spraying water,
Yeah.
the water would not be going in meter cube, would it be? It will be going on the area which is on the top. And for 1 square meter area, would you be spending $3.80 on water?
So I don't know about the price, but from this price,
1,000 liters of water, if you check your bills over there, cost you around $4. So you're trying to say over here that curing, because it uses water, one square meter would cost you $3.80.
not 1 square meter, 1 meter
It
cube.
will be water would not go into meter cube over there. Is it going inside the concrete? No, it's just sprayed on top there.
But you have to cure concrete regardless of the strength though, don't you? So
Yeah, curing is happening
yeah.
all by itself basically. You leave it for 14 days, it takes the strength, because concrete comes with its own amount of water which is required for it to cure. You
So
do
it's
not-
like the polishing and the finishing, it goes by square meter.
Yeah, and that is not the. So what I would say is just this thing is basically all the prices given up over there are 20 MPa. For 25 MPa, you are adding $3.80. And for 30 MPa, you are adding $20.80 extra.
What about for 35 MPa?
Yeah.
I don't think it is given over here, but if you go and check if you type in 35 MPa, just type in 35 MPa in your search over here. Do the
But
search.
no, I searched it, but there is no price for the 35 MB.
Just search it. Just search it, Chandra. Just make a search. Control F and search 35 MPa. Do Control F, put 35 MPa.
Right.
You got the price now?
Yeah, 35 MB extra for, yeah, it's come under estimating rate excavation, international construction cost.
So that's
Yeah,
your
this is-
introduction.
Yeah,
I
international.
think, sorry, I just interrupt a little bit. I think Naru before said another way to do it. If, for example, you have 30 MPa and 25 MPa the price, you just actually, calculate the difference. For example, before you had 30 MPa is $30, for example, and 25 is add another $3. If the difference is $27, you just add another $27 on the top of it for the extra 5
That's how
MPa.
you assume. That's a good way to do it.
Yeah, just assumption, just that you're doing like that way. So you can, at least you can add on another 5 MPa.
Yeah. So what is happening is from 20 to 25, the increment is only $3.80. But from 25 to 30, the increment goes to $15 or $16 from there, basically. So you add another $16 or maybe $20 to go from 30 to 35. That's a pro rata way of doing it. So that's, you are assuming something, and then you write in your assumption that we have assumed the 35 MPa concrete rate to be $50 more than 20 MPa as given in Rawlinson.
Okay.
Can I ask something about this as well?
Yep.
On the page that Chandra was on before, about strip footings, the
Yeah.
heading for that was reinforced concrete.
Yep.
Yeah.
But then in all of Ronnie's examples, he's calculated reinforcement in addition to the price, like he's in the, what is it, the composite rate or whatever, he's added extra for reinforcing.
Yeah, so he has not picked up the right rates over there. So you need to take the rates which is unreinforced basically, and then you do your reinforcing separately.
Okay.
So
And also for RJ, since we have that problem, and also, it's I think it's 100 kg per meter cube
Yeah.
for the I think reinforcement. But actually the Ronnie just gave us 80. Shall we just adjust to 100?
that is for that example, he has given you 80. When you
Yeah,
would
but
would calculate it for your thing, now if you go and calculate, say, let's go and pick up one strip footing from your example, or one pad footing over there. Let's go and see one pad footing. Chandra, can you stop sharing?
yeah, okay.
Okay. Now let's go and see the details of one pad footing. These are the details of a pad footing. All right. Now in this pad footing, you can see your bars, U bars over there. So if you guys have calculated, you would have calculated 4 plus 4, 8 bars in one pad footing. And you would have calculated the length of each bar. So this is H12 bar over there. What is the length? So you got 800 minus 50.
It's 9.6 meters in total.
Yeah, 75. So it is 75, 75. So 9.6, you said?
Yes.
In total? That's the total length of 8 bars, because one bar would be 800 minus 75, like 150.
1.2 per bar.
And this is 50, and So you got 50 plus 75, 125. So you got 400. So this is 1.2, you said, Baba, isn't it?
1.2, yeah.
Yeah. So 1.2 times 8 bars. You have got those many bars. What is the length of the bar? 1.2 times 8, 9.6. Now H12 bar, what is the factor for H12? Is it 0.888?
Yes.
You multiply it by 0.888. kgs. So it got 9.6 meter into 0.888. So you got 8.52 kgs of reinforcing happening over there. And your pad, that gives you an idea, like this pad is not that heavily reinforced because it is just 800 by 800 square pad. Yeah.
With regard to SF4, because there's two different types of reinforcing in there. So when it goes under the roller door threshold, there's more reinforcing in that part. So would we break that up into two?
Yeah, but see, what I'm trying to say is either you go and check what is the reinforcing happening in 1 meter length of this SF3 or SF4, and then you calculate your reinforcing, measurement over there. So if it is all H12 or H16, so you measure them for 1 meter, how many times your starter bar is happening in 1 meter, how many times your R10, 3 legs stirrups are happening over here. How you got 1 meter length of your these H16, horizontal beams happening over there. So you measure the total weight happening in 1 meter of SF3.
Yeah, but what do we do if there's two different amounts of reinforcing in the same strip thing?
Yeah, so if you got two different amounts of happening, from this, say for example, your strip footing SF3 is going from here to here, but at certain junction from this line onwards, you're reinforcing, maybe more, but it's happening only until here, and then again it is the same thing. So you basically, what is the length of the total reinforcing for SF3? So if the total length of SF3 is 10 meter, and this length is probably 2 meters happening over there, where the reinforcing is quite heavy. So what you do basically is, 8 times of this thing, the weight over here, 2 times of the weight happening in this element over there. So you add them together, divided by 10, and you got an average weight happening for the whole 10 meters. Isn't it how you do your averages?
So RJ, so we need to actually do it like this way.
No, you don't have to do it.
This,
It is when you want to be actually precise with what kind of reinforcing going over there. You should basically go and check your elemental rates. You should never go into your detailed rates. I don't know why you are going into your detailed rates over there. Go and check your elemental rates first and see what is happening. So if I go, stop sharing this thing, and I find out my.
So you're saying it doesn't matter if it's if one part of a strip footing is heavily reinforced and then the rest of it isn't so, is that what you mean?
For your estimation purposes, you need to understand, Monique, that you have not been given detailed drawing. What you are telling me is what you have observed from the detailed drawing.
Oh, yeah.
So
Yeah.
there is a distinction over there. You're not, now you are wearing 6035 cap.
Yeah.
So there's no details given to you. So when there are no details, you cannot, tell that no, for 2 meters, the reinforcing is, 20 kgs more, because you do not know.
Yes, you're right. Yeah, that's right. So should we do an example then of a strip footing
So
then?
what you need to do is basically you need to go and check your, let me just. And you need to go and see your elemental rates, not your detailed rates over there. So go and check your elemental rates under Rawlinson. So sorry, I got that elemental analysis book over here. I don't have Rawlinson on me. Go and check the elemental rates first. And in elemental rates, you would find it mentioned as like 600 by 300 footing with 100 kg per meter cube of reinforcing. And there is a cost given to you.
Yeah, I can share the
Yep.
Rawlinson. Yeah.
Yep.
Yeah, it's
What are
Elemental.
elemental costs?
yeah. So here strip footing is come under substructure.
Yep.
So foundation, in the under foundation, here strip footing is given for 25 MVA.
So that's a rate given to you.
Yeah, but that is for the 100 kg per meter cube. Say if
Yep.
it is 80 kg per meter cube.
80 kg was given to you, for example, over there. For
So
the
we adjust to
calculation
100,
purposes.
right?
You do not know. You do not know if it is 100 kgs or you would assume it with the 100 kg. You will go with the high estimation.
Yeah, we're not adjusting anything. We're just going by that. Yeah.
No, yeah. Say sometimes if I want to go for 120 or something, then how can I do this one? The
Chandra,
reinforcement.
Chandra, on your assumptions, you go generalistic. You do not go as per your whims and fancies that you want to go for 120. Whatever rates are given based on those rates, because it is elemental cost. You're estimating right now. You're assuming lots of things. Unless it is given to you, it is 120 kgs. That means there is a detailed drawing given to you. That's how you found out it is 120 kg.
So then for foundation and other like a slab or some other parts also
You
are,
would go with the journalistic approach. Whatever is given in your Rawlinson over there, that is the journalistic approach. You will go with that. Because you have not seen the details of this reinforcing happening in the slab. You have not seen the details happening of reinforcing in your strip footing.
but the Ronnie has given the 12-page as a drawing to us. So in that case, we can go and measure it, the reinforcement, how it's weight for the meter cube. So different footing, different strip footing have different weight.
It's all here. Reinforcement already included in the strip.
Why would you do that? You would
You don't
measure
need
it
to do
only when
that.
you will be given detailed drawings. Why you want to do that?
No, I think Chandra's trying to say that if we are to go by not the drawings that Stuart gave us, even though they're part of the same, but if we're to go by Ronnie's drawings that he supplied, then we can work it out. That's what I think she's trying to say.
The
Yeah.
drawings which Ronnie supplied, I've not seen those drawings.
Yeah,
But how different it is from this, the one which has been given by Stuart or Ernest?
same.
I
Same
think,
structural-
yeah, I think Ronnie's like he's given us half of the pages or something.
Yeah, because
Yeah.
that is what you should look into, because you
No,
should not be
structural
getting-
drawing same. Structural drawing 23 pages. But
Okay.
sorry,
Yeah.
sorry. Architectural drawing only 12 pages.
Mm,
Architectural drawing 12 pages, and even the structural drawing should not be there basically with you, all 23 pages. There should not be any details given to you.
yeah.
All detail, you should be only getting first 5 or 10 pages of the structural drawing.
So basically just work off this, if we're using Rawlinson's, just use this and stick
Yes.
to the 100.
You see
Yeah.
this thing. Now this strip footing, they have given you per meter cube right over there. So it is, 25 MPa concrete, 100 kg per meter cube formwork, and shallow excavation. So shallow excavation is basically up to 300, 400, 500 basically. You're not going very deep. So
But
this,
this. Mm, yeah, okay.
all right. So your rate is 1510. And that rate you would apply everywhere. All you need to see what is the volume of your strip footing, and you multiply it with the meter cube rate. So if your volume comes out to be 45.45 meter cube for 1 meter length of your strip footing. So it is you multiply it by 0.45, and that is your rate for per meter cube of that strip footing. It makes your life very easy.
Yeah, very easy also. If I
Yeah.
start to calculate from the build-up, detail rate, is I'm not getting the even very closer to cost planning rate.
That's why
Cost planning rate.
That's why I asked you to come to this rate.
Yeah, this is much accurate. I think if we
Yeah.
if we start to do with the
And
build-up
you can
rate.
do all your strip footings, all your toe footings from here basically. You don't have to worry about anything.
But that includes formwork as well.
It includes everything. It has
Yeah.
given you the rate breakdown at the bottom over there.
Mm,
So everything, your excavation is there, your backfill is there, your concrete to base, which is your side concrete, which is 50 mm concrete is given to you. Your concrete 25 MPa concrete is given to you. Your formwork is given to you. Your reinforcing is given to you. Everything is given to you, and it comes to 1514, and that's the rate which is given to you. 1510, which is given to you over here.
I'm just a bit confused because Ronnie gave us an example of the spreadsheet, and he also gave us an example of his calculations, and he got them all. I know it's here, which makes sense, but he got them all separately from the detailed trade rates.
Yeah, see, that is the second way to do it. If you do not find anything which is relevant to your requirement. So for example, it is for strip footing, but you are measuring for foundation beam. So for example, now you are confused that foundation beam is not mentioned, and how would I calculate the rate for a foundation beam? Then you go and pick up and build your rate basically. So what is happening in foundation beam? You still have to do your excavation. Yes. You still have to do your side concrete. Yes. Do you still have to do concrete pouring? Yes. Is there a reinforcing going? Yes. Is there formwork happening? Yes. And that's how you build up from your detail rates over there. And then you come to your foundation beam built up rate for 1 meter. So sometimes not everything is given over here. Or the other option is, what you do is you assume that cost of the foundation beam per meter cube is same as strip footing. That is my assumption. And it uses the same amount of reinforcing. That is my assumption. And on the basis of that assumption, I have calculated the cost of the foundation beam.
So what is the further down? It says rate per lineal meter. What is that? Would that be like, what is that?
The one on the top is your cubic meter rates. Those are your linear meter rates.
Okay.
So a 300 by 300 deep strip footing
Mm,
would cost $136 per linear meter.
mm. Yeah, I did done a couple as well, and actually one of the other students has mentioned in the chat that she did a length of strip footing and come up with a crazy amount of money.
Yeah.
So
Now,
this 1510 seems
there is a very good,
crazy.
yeah, there's a very good observation which Ranlong has just mentioned. The build-up rate which Ronnie did was for linear meter. So he created the rate which was for linear meter, from everything from square meter to meter cube, because different components have got different different units for measurement. So formwork has got square meter, concrete has got cubic meters, side concrete has got square meter, excavation has got cubic meters, steel has got kgs. Everything was converted into meter
First, yeah.
for
Yeah.
1 meter. So that is what the built-up rate basically was there, which Ronnie did. This rate breakdown, which is shown over here, is cubic meter.
Yeah. And so we don't have to do it all separately, as in the formwork separate. So this here, this one at $1,500
That will do all your foundation, all your strip footings. There's a foundation beam rate with 30 MPa given at the bottom.
Yep. Add
So,
that. Yeah.
And then
And so,
similarly,
and what about
similarly you
the, sorry,
you
what
get it
about,
for the slabs as well.
and what about the toe footings? Is that considered, would that go under the strip footing as
Strip
well?
footing and toe footing would be the same.
Even though there's a lot less reinforcement in the toe footing.
Yeah, you do not know. See, Monique, you're again going back into the detailed drawings.
Mm,
You do not
Mm.
know that it is a lot less or a lot more. So
okay.
you'll assume it as a strip footing.
Okay.
That is what I'm saying, because that is where the confusion comes, because you have got your concept of 6033 and 6034, and you're mixing that concept over here in 6035. It's not happening. 6035, altogether a different cap.
Yep. So just go by this, and then we can
Yep.
about the, yeah. Hey, I've got to go, RJ, but I was wondering if I could email you something tomorrow for you to have a look at quite urgently if you've got the chance.
Yeah, send it to me and I'll try my best.
Yeah, I can't do it tonight because I've got something
Yeah.
to do now, but yeah. So thank you very much.
No
Appreciate it.
worries.
RJ, can I ask, since the Ronnie's example, I just use the detail rates for each one Ronnie did. I
Mhm.
used the QV cost builder, but
Mhm.
as you said before, like the strip footing or the pad footing, we actually can use that rate just for the cubic meter.
Yeah, you can use that rate over there. Just remember, these are Rawlinson rates. So these are from 2014 last quarter or 2015 first quarter. You need to adjust them to the current.
I used the QV cost builder actually.
Yeah.
But actually, Ronnie told us how to calculate like each strip footing, toe footing. But as the book from here, it's kind of directly just.
Yep, use this one straight away.
I already done Ronnie's way. I just want to ask.
Yeah, you can do both ways basically. That's not a problem.
And also, if you have time, can you just go over for the element and analyze book? Just maybe highlight which one we should calculate, or I can tell you what I did, and you can you tell me what I'm missing or something like that.
Yep, you can share that. You can share your Elementor.
I got all my answers for my one. I can just tell you which one I did.
Mm-hmm.
I will share the just hold on. I just tell you what I did for the right now.
Share the Elementor book basically, not your PC.
Oh, okay. Okay, just hold on a second.
Yeah.
Hey, RJ.
Yes, buddy.
Sorry, after this, do you mind just talk about the tanking, roughly, like how do we measure tanking? If you can, thanks.
Tanking for which assignment?
Yeah, for 6035 subscription.
Okay. So what did you do in E1?
Is she talking about Emil?
Yeah, I think she's on mute. Or what?
Oh, sorry, I mute. Sorry.
Yeah.
Oh, for the first, the site preparation, I did these three. I
Mhm.
did the site clearance, bulk excavation, and also bulk the filling. These three I did for this part. Is anything I'm missing or we need to calculate? Can you give a hint?
1.09,
This
do we? I think Ronnie sent an email today that given an allowance for that, but give it a
You should
stop.
put some kind of allowance if it is given you like $10,000, $5,000, whatever. Okay.
yeah. So that one I'm missing. So I will do that one, and after that, here this part substructure I did the strip footing and the toe footing, pad footing, this part, and also the concrete, the slab, concrete slab for 150.
You will be doing 2.03, 2.04, 2.05.
Yeah.
There is no filling under the floor slabs. I don't know if there's any additional filling going under the floor slabs for you.
I can't see any. And
While
also,
we are on this page, so when we do the 2.03, the footings, are we going by sizes of the footing, the straight footing, like, or are we doing it like, because we can do it 2.03.1, right?
Yes, that's why, because each strip footing have got a different cubic meter volume, isn't it? Because your height, your width is different.
Yeah.
So your rate would be different for each one.
So we would have to calculate our straight footing, I mean
2.04
footing sizes by
Yeah.
footing by
Two-
sizes.
Yep, 2.03.1 would be one size, 2.03.2. So you got 5 strip footings over there. So 2.03.1 to 2.03.5 is your strip footing.
Because
Then
because
you
we
got then you got
because-
5 toe footings. So 2.03.6 to 2.03.10. All your toe footings would be like this.
yeah, so when we do our toe footings, are we using it? Are we using the same descriptions only?
Yeah.
Because we're assuming it's as
the
same
rate,
sort of
right?
stuff,
Yep.
same sort of design as a straight footing.
Yep.
Yeah.
So there'll be 12. There'll be the pad footing, 5 strip footing,
Pad
Pad
footing
footing is
that one?
2.04.
six toe footing.
Pad footing It's under the 2.04.
2.04.
Yeah.
Straight footing is 2.04. 2.03 is all your straight footing and toe footing.
Yeah, I know. I'm just saying that there's going to be 12 in total.
Yeah, I don't know how many straight footings.
I
you've
think
got.
11, one is 5, one is 6, 11.
Yeah,
for the
11. So yeah.
2.3, yeah.
Yeah.
2.03.
Yeah, no, what I meant was going to be 11 and 2.03 and then
Yep.
1 and 2.04.
Yep.
So after that is floor slab. We're doing that for
Yep.
150 millimeters.
So you got
125.
150 and there's 125 as well, isn't it?
Yeah. And
That would be two different
yeah.
items, right? Like 2.05.1
And 0.2, yeah.
and 0.2. Okay, good.
Do we need to put the top? Do we need to put the second floor actually the suspended, the floor slab on that under that one?
No,
Or
that's not an element 2.
Or
That
it
is
will
not-
be the start.
It is not
upstream.
substructure.
Okay, yeah, that's cool. So it will be over that one, right? 2.07 for the top footing we just talked about, the suspended floor slab. That one for 2.07. That's
No.
what.
No. This is not substructure.
Substructure is on the ground level.
So not that one. No 2.07.
No 2.07.
See, that is for a suspended concrete floor at ground level. So it's not a concrete slab on grade. It's a suspended concrete floor, but it's still sub-element.
Like in
Okay.
a basement or something.
Yeah, or whatever.
Okay, so I didn't do anything from the under. So is anything we need to do from here, 2.08 to 2.13?
All right. So now over here, somebody asked about tanking,
Yeah.
which is 2.10.
Mm-hmm.
Now, where does the tanking happens? Tell me, under substructure, where would you do the tanking? Would you do the tanking? What exactly is tanking? Everybody understands? What is tanking?
Waterproofing,
Waterproofing, yeah.
Waterproofing, yes.
DPM.
You not DPM.
Oh.
Tanking
Ah,
you,
yeah.
Is that the things go around the PCP?
it
Under the
can be
ground?
around the PCP as well.
Yeah,
But PCP is not your substructure, is it?
yeah,
That's your external walls,
Yeah.
structural walls.
yeah, that's structural work.
So in under substructure, where would be the situation where the tanking would arise? Would be required.
A rotating wall. No, not rotating wall.
Retention wall.
Yeah, like a under basement wall, that sort of thing
Yep.
that
Correct.
needed because it
So-
needs to be.
If you go up over here, who's sharing the screen? Ellen, if you go up. Go up. Go to this diagram. All right.
Yeah.
Now you can see there is a wall happening on element 2, where the element 2 is mentioned. This wall, can you see my cursor over here?
We can't see your cursors at all.
You can't see my cursor? Okay.
Is that the one in the middle?
Yep, the one in the middle here. This one.
Yeah.
All right.
Between element 2 and element 3 and 4.
Yeah.
That
So
footing.
So where would be the tanking happening? Now, if this is a block wall going over here, tanking would be happening on this side. Tanking only happens when the other side is open and is for use.
Oh, we can't see.
You can't see? All right. If I can share my screen, then I'll.
You mean the left-hand side of the middle wall?
Yes. So I'll share my screen. So. So in this wall, this is an open area. this is exposed to the ground. So the tanking would be happening on this side. So they'll put bitumen and some plastic membrane or something over there to make sure that water does not seep into this thing and comes out over here. Right? So this is where the tanking would be required. In this whole diagram, this is the only area where the tanking would be required. Now, do you, in your drawings given to you, can you see anything like this happening anywhere?
No.
No.
Not
no.
even grid, not even on grid line 19. It's a
no.
wall, but it's exploded.
Yeah,
It's underground, I think.
it is not something is substructure because you got your PCB panel starting from here
Yeah,
going up over there.
yeah,
So yes, there is a bit of tanking happening on PCB panel, which is underground, but that's not substructure
yeah.
because that PCB panel is part of structure
Structural
walls. So any tanking happening in your substructure anywhere?
Well, I don't know what waterproofing members. I think it's the DPM.
Yes, DPM is a different thing.
Yeah.
It's not
Other than
tanking.
that, I don't think so.
So
So
there is no
any-
tanking happening. Tanking only happens where you got some kind of, you got your strip footing over here, and then you got your block wall going on top over there. And this
Yeah.
is like all underground. So
Yeah.
you got ground, your finished ground level is over here. And then you got your finished floor level happening over here. And you got your slab, going all the way over here, basically on the block wall. And there is a distance of 225 between finish FGL to FFL. Right? So tanking is happening at this site, you'll have some tanking happening over there if there is a block wall. Even that is not required. If it is a basement scenario, your slab is, say for example, your slab is not happening over here. This is your, you got ground over here outside, but you have dug it and you created a basement over here.
Yeah. Created a
So then
space.
the tanking is happening over here. So tanking is mainly happening where you got some kind of retaining wall. And the other side of the retaining wall is open area for consumption for use.
Yeah.
Right. So you would not have, I don't think there is any situation where you would be having any tanking happening in your substructure.
Yeah.
As far as my knowledge of your drawings goes, basically. Though I have not seen your drawings very carefully, but whatever I've seen, I have not seen any scope of tanking anywhere. So your element 2.07 is not applied, or 2.010,
Yeah.
2.10 does not apply in your drawing.
Thank you.
Mhm.
Okay. And
Could you just
And
go up
we're-
to level 2? Could you just quickly go up to level 1 so I can look at something? Sorry, Ranlong.
it's okay.
Which one?
Just want to have a quick look at the element 1. Okay, so 1.08, what is that?
If you have got a current, you did demolition over there. So when the demolition happened, so that means there was an existing building over here. So there could have been some services running underground. There could have been a drainage system happening, you know. There could have been your electrical works coming underground over there. There could have been, you know, some kind of services happening for the building which was there, which got demolished. So you need to
Okay.
divert those existing services.
So how would we know that?
Now, in your current drawing, was there any building before there?
No.
No,
So would there be any existing services over there?
no.
I think if you have an existing house, you have to contact Water Care to do something called works over or something, applications to disconnect or whatever is it.
Yeah, you need to terminate that service and you have to
Yeah.
divert it somewhere else.
And then you have to call the power company and also to do some service to get the site ready. And that makes sense. I mean, yes.
So from here, we're doing 0.02.
I think 0.02 has been from the client instruction it has been done. Am I right, Ajay? So we shouldn't do any calculations related to site clearance because it's done by the other. And most of our excavation is done to reduce level as well. The site is completely quite close to be ready for the footing change excavation.
Mm.
Am I right?
But we need
I
to
might be wrong.
Now, I will not answer this thing because if I answer this thing, you guys would be very happy.
Okay. Am I close to where it should be?
You just see, but my suggestion to you is please do your 1.02, 1.03 and 1.04 for your understanding.
Okay.
If you do it, you would have much more clarity as what is happening over there, what are the measurements, you know, how we come to those kind of measurements. Because what client instruction has been given to you, which is same as what Stuart has given, you know, for his excavation work.
Yeah.
So the site has been enabled to FSG levels, basically.
Yeah.
So if you have been given a site to FSG level, that means your 1.02 has been done, 1.03 has been done, 1.04 has been done.
Yeah.
So what are we not? So we're not doing anything on element 1, other than what we just mentioned.
I am not going to answer that question.
Well, according to the client instruction, it's not much things to do in element 1, except they are probably because we have to backfill a bit to the back to the
FSG.
slab level, because we need to be back to the slab level. I think that is a bit of backfilling. Then we have, yes, the 1.09. According to the email that this morning or this afternoon, I think, Ronnie sent, we just have to be allowing an amount for that dewatering. Is that so? Well, Ajay just say if we can do 1.02, 1.03, and 1.04, that will make us much more knowledgeable about that element. That's good.
Yep. What I would say is, if I would have been you, I would have done 1.03, 1.04, 1.05 for my own sake, for my own learning.
Yeah.
And underpinning is something when you got any existing, you know, footing or existing wall, you know, next to your site, which is at very close proximity. So you go and underpin it to make sure that when you do your excavations, it is not damaging the footings of that particular wall, which is, the next adjacent building to your site. So I don't think you got anything like that adjacent to your site. And so there's no underpinning over there. There's no support to existing structure because you're not doing any shoring because there's no structure close by existing. And then there was no structure before over there on that site. So there's no diversion, no termination of existing services happening. Dewatering, yes, you have to put some amount for dewatering because you never know when it rains. And you need to have some kind of contingency or, provisional sum for dewatering over there. So that is the sum which has been mentioned or been given to you.
Do we have a percentage?
Yeah, whatever has been given to you, like, I don't know.
Okay. Whatever.
The temporary ground retainment, that's along grid line 19? That's what that would be about? 1.05?
Temporary ground retainment is where you have got a lot of, you have got a steep cut. You have done excavation, you've done a steep cut, and you want to retain that cut. Otherwise, that there would be a fall happening over there. You understand what temporary ground retainment is?
Yes, sort of. Yeah.
Yeah. So you have got this as your ground level, and when you start doing your cuts, you do your first cut over here and you bring it over here. Then you do your second cut like this and bring it over here, and third cut over here. So this could be 2 meter deep from the current ground. So you have got this ground, and then there's a deep cut coming over here. So you do a temporary retainment over here. Similarly, you do a temporary retainment over here.
Ah,
Yeah. Because otherwise the top part will just collapse in on the second.
Yes. So it
Yeah.
will collapse basically as soon as it rains. It will collapse like that.
Mm. So you think we should do that? Yeah.
If it is required in your thing,
Mm.
you need to see if it is required or not. And again, I go back to that client instruction and see if it is required to be done.
oh, okay.
Okay.
Yes.
Yeah. Sorry, I can't seem to find the right sub element for sprayed concrete wall on the E2. On the grid line 19. Sprayed
Yeah,
concrete.
the sprayed concrete wall.
Yeah, I can't seem to find the right.
So there's anything called as retaining wall over there?
A lower one, I think. Lower page, I think they do have something like that.
Basement wall? Permanent
Do you
ground.
think that,
retaining-
yeah, do you think like the basement walls? Huh?
That's bulk filling around basement wall. So you need to know your basement wall probably would be part of. Okay, now you got a very valid point over there because that is kind of a wall which is happening. So where would you calculate that particular thing?
Can we do on the 2.13? It's permanent, like the ground retaining wall, something like that.
Permanent ground retainment.
Can we do like from there?
So area of face retained in meter square. but there is a reinforcement going over there. There is a no. I would rather calculate it. Send an RFI to Ronnie on this thing. It's a valid question. Should it be calculated under 2.13 or should we calculate it under 2.03 as in a pro rata basis? You know, as one of the, it could be like one toe footing, which is rather than being like this, it is like this.
Ajay,
Yeah.
I remember someone asked the same question in the class, and they said, yeah, we should include that in 2.03.
I would do that in 2.03, but you can ask, you can verify this question. Because for
Okay.
me, it is something like a toe footing, which is not happening horizontally. It is just happening vertically.
Okay. Yeah. Thank you.
So it would come under the reinforcement part where it says strip footing. So it's reinforcement.
Yeah, it has got reinforcing. Yes, it has got only your D16 and D12 going over there.
No, I mean the purpose of the wall is a reinforcement, isn't it? The purpose of the wall.
Purpose of the wall, see, you have got a PCP panel. To stabilize your PCP panel, you get a toe footing over here, which is horizontal. Sometimes you have got something happening like this as well. It's again doing the same purpose.
So it's just reinforcing that external grid 19.
Yeah.
Yeah.
All right.
Shall we keep going?
I don't know.
For the, after that, as I said, from 2.07 until 2.13, I didn't do anything. So do we need to do anything from that part?
You need to see if there's anything happening. 2.06, is it happening in your scenario?
I don't think so.
Is there any suspended concrete floor slabs? I've not seen any.
No.
Under slab service ducts, including excavation, concrete. You do not know. Have you been given any details of any service ducts? Is there any ducts coming for your, if there any council water line going below your thing, and then you have to make some ducts on top of that.
I don't think so.
Is there any lift and escalator happening?
No.
Tanking we have already discussed. Is there any timber floor on the ground level?
No,
No.
Is there any basement?
no,
No.
no filling around. No backfill. Is that backfill? Yes.
Yep. And
Yes,
is
we
there
do
any
have back.
retaining wall?
Yes, we do have filling.
Is there any retaining wall?
It's just the same wall that we just talked about, is it? The
I would
grid line
just say that
19.
it will be on under 2.03.
So you got your answers basically.
Yeah,
The-
after that.
The important thing is,
Do we have to be filling that up back to the slab level?
what goes, I told you the other day, basically, you have been given a ground which has been prepared to FSG level now.
Yeah,
So what goes on top of FSG? To
Hard
finish
fill.
floor level.
Mm.
This is your slab over here.
slab, yeah,
This is your
sand
FFL.
blinding, sand blinding, dim
you-
half fill,
DPM.
So
Yeah.
you got your
yeah,
DPM,
DPM, yeah,
Yeah.
DPM, sand
That's it.
blinding,
and you got your
then the
sand
half fill,
blinding.
yeah, and then the half fill.
And then the
Half fill.
remaining is your hard fill.
Yeah,
So is there any bulk filling happening? Anything happening?
I thought it was,
Remember bulk filling, there's a difference between bulk filling and hard filling.
yeah. Bulk filling is because we need to backfill like the change,
Yeah,
right?
yeah. So
It's
bulk filling is
after
what
the
you have
concrete that we need
excavated.
to, you need to fill those gaps.
Yeah, so what you have
I mean,
excavated,
walking space.
yeah. So you're filling back the ground,
Yeah,
but you're not filling back the ground over here. You're doing the hard fill. So it is different thing going over there.
is it all half fill on grid lighting as well? Between grid 19 to grid 18?
Okay, let
That's-
me go back and explain you one more time, although your excavation or groundworks thing has been done long before.
Yeah.
But
Because I remember I calculate some backfill on that space.
so you go back and see these two drawings over here.
Yeah, that footings.
Yeah. So when it says the site is enabled, what does it mean?
Means that the site clearance has been done, the strip level topsoil been done, and the bulk excavation.
Okay. So site is enabled to FSG level. What does it mean? Let me rephrase myself.
Is that because it's the original ground level is slow? So this is probably
All right.
slow.
So
Let's
it's
go
like
back. Let's go back
350
and see what is this level.
FSG.
FFL.
Oh, so FFL and the lower
Yeah.
is FSG.
So this is FFL. Where is FSG? 350 below FFL, isn't it? So you got your 125 slab. Then you got 25 sand blinding. And what you'll be having?
Hard fill.
Hard fill 150.
So 150 hard fill. So you got 150 hard fill. So in total 125 plus 25 is 150 plus 150 over here is 300.
Yeah, but sometimes they have 150 for the slabs. So yeah.
So your FSG is over here somewhere. Because from here to here it is 350, isn't it? So when you went to the site, you are getting a site which has been enabled to this level. Whether it is grid line 19 or grid line 10. it is a common thing that the site has been enabled to FSG level, which is 350 below FFL. Wasn't that the clear instruction given to you?
That was the answer from Stuart on the class when I asked him for the first time.
Yeah. So
So have the the workers that have done that, they have, regardless of the slope, they have backfilled up to FSG.
FSG.
yes, that was the instruction given to you.
Super clear. Yeah, fully understand now.
So we've only got to do from there below. Okay. So that will be some backfilling.
So if
That-
there's any backfilling happening, if you got only hard fill of 150, so the backfill is happening only for this 50 mm, isn't it?
Mm-hmm. Mm-hmm.
You would rather have a hard fill of 200
Mm-hmm.
continuous on this side as well, rather than having a additional backfill going, and you will be bringing your, because that backfill is a very different kind of backfill. It is a compacted backfill. It is not normal backfill, so you have to buy this thing. So your enabling work has already done this thing for you.
So do we need to, we've got to take into consideration the backfilling around the strip footings.
Your backfilling is only happening where you are doing your excavation, which is element 2.
Yeah. So basically there's no backfilling in the element 1 at all. Yeah. Okay. Element 2. I mean,
Element 2, there is a backfilling. Element 1, there is none.
Element 2 is because we need to backfill the trench.
WSA, you're doing
the
your
walking space.
working space, you're excavating that, you have to backfill that.
Yeah. After the concrete poured, the firm wall is gone, then we need to fill that with the backfill.
Which you are calculating in your
Footing.
element 1, element 2,
Element 2 is that?
strip footing
so-
2.03.
yeah, 2.
Yeah, 2.03 is already included.
Already included your backfilling and everything.
Yeah.
So if you look at it, it's very easy what you're doing right now in your
Yeah.
6035.
Right.
If you
Because it's a
understand
whole lot
the
of
things,
information. It just
Yeah.
take time to digest it.
yeah, if you understand the information, you will have a very clear picture what is given to you and what you're going to do.
Mm-hmm. Okay. Okay, I know that you mentioned that we should do element 1, the site clearance and things like that. If we do it according to the client instruction, we won't get marked down, right? If we haven't calculated that, but we do it according to the client instruction.
Because you have to refer to that client instruction, saying that client instruction says that site has been enabled to
Yeah,
FSG levels.
yeah,
So which means all the bulk excavation has been done.
yeah,
All the backfilling has been done
yeah. All right.
for element 1.
Yeah, for element 1. Okay. That's good. I got my answer then. All right.
That's work to do.
I just want to make sure that we won't get marked down first, okay? You guys heard
If,
that?
if we get it wrong, we might be get marked down. So if we don't do it, it will
Okay.
be
We're only up to element 2. Can we look at element
4.
4? One of you
Excuse me,
guys.
We just quickly go through it. We just quickly go
excuse
through.
me, I just
Yeah.
want to clarify that we don't need to do anything on element 1 because of the
I'm not
instruction.
giving any more answers now. Like I'm
He's not answering that question.
1.09 for, you have to assume a sum, the rest
Yes.
should be fine.
Yes, we
and
need to allow a sum.
wait, just allow sum for 1.09. Rest, if you want to do it, you can do it, or you can just refer to client's instruction.
Where should we get such kind of sum for the 1.09?
Assumption. Is that $10,000 or one
Okay,
plus contingency? You can
okay, got
just
it, thank
do
you.
it. And for the structural wall, RJ, I did 150 millimeters precasting wall panels for different types, or including one title. Another one is 200 millimeters reinforcement precast concrete wall panel. That's what I did for the element 4.
Yeah. So like go with the drawings which has been given shared by Ronnie, the architectural drawing. And what you can see over there, what kind of walls are there. And,
Yeah.
And based on that, those architectural drawings, you do your measurements.
Yeah, that one already done. I just want to check like any the the subheading I forgot. So that's what I did for the panel. So, and after that is roofing. Roofing I did 6.01 and 6.04. Sorry, I can't. If you can go into the roofing part, I did 6.01.
The structural walls, you don't have many components. You've got
Yeah, just one.
4.101, 4.02. That's it. So all your concrete walls would come into this. So 4.01.1. And you need to understand structural walls are the walls which carry the weight, which are part of the structure. Any internal walls which are not carrying the weight would not be structural walls. So you need to make sure that if there is an internal wall, is it carrying any weight? If it is carrying weight of your suspended floor, then it is a structural wall. If it is not, then it is not.
So you mean for the precasting panel, internal precasting panel, we don't need to count it into this part?
I'm saying structural walls. You need to understand what is the structural wall.
If the wall have to take the load from somewhere, maybe upstairs, then it is a structural wall.
If the wall is taking the load to your ground or to your strip footings, then it is a structural wall. And most of the time it is your external walls which do the things. But there are occasions when your internal walls can be structural walls as well.
So for example, for the grade 15, they have the one of the, I think the panel, precasting panel on grade 15 next to the stairs. So do you think that's a structural wall or not?
You need to answer that thing.
Oh, okay, I will go double check.
Yeah.
And also, do we need to doing the fair face finish for that part for the 4.01?
Yep. So you need to see what kind of finish it comes. The external wall are coming. So all your PCB panel comes with a different kind of finishes. So sometimes you got a design on top of that. Sometimes you got a plain, finish. But they all have to be having a good finish because most of the time they are external walls. So they need to have a good finish. If you've got a structural wall which is inside, but has it been cladded with lining? So you might not be worried about finish over there because there is a chipboard going on top of that. But for
Right.
your external walls, you need to be worried about your finish because that is what is seen from outside.
So that's only one side of the external. So you're talking about the external wall.
Yeah, you need to see your drawings and see which walls, which panels need
Yeah.
good finish.
When we talk about this finish, is that one side of the wall or both sides of the wall?
Or could be one. That's what he's saying.
So we have to check the drawings there.
Mm. So
Okay.
an external wall, the external part of the external wall may have a fair face finish, and the internal part of the external wall could be lined.
Could be, yeah. You need
Could
to see
be,
it,
yeah. I think it's if it's in the showroom, it's lined, yeah.
So for substructure, we're only looking at 4.01, right?
Yep. Is there any masonry wall in your thing?
No,
No.
No.
Yep.
Yeah.
So when
So
there are
what
no
about-
masonry walls, you don't have to worry about it.
What about element 6?
let's go down. Go down.
Yes, well,
Almost to the end.
we nearly
Almost to the end. Okay,
Um,
moving.
what I did is I did a 6001, 03, 04, 07. Oh, sorry, no, 07, 04, then 08, 09, 11. That's what I did. Is anything missing from here? So I didn't do 2, the deck, I didn't do it. I did do 5 and 6.
All right. So O1, you know what it is. So
Yeah.
all your color steel and so that
Flashing.
will be, yeah, with the flashings would go into that. 602, it's not happening in your scenario because you don't have any awnings or
Okay.
deck coverings or anything over there. All right. Now 6.03, you
Oh,
have
sorry,
got
I didn't
them.
do.
You got your bracings, you got your sacking, you got all that is happening over there. 604 happening, you know, it's happening in the office.
Yeah.
605, you don't have any soffits. You don't have any soffits on each sides.
Mhm.
So nothing on the bar side, nothing on the eave side. Do you have any parapet gutters? You don't.
No,
No.
Yeah. we
Sorry.
don't have it.
Right. But you do have eaves gutters.
Yeah, you've got
Yes.
the down pies.
You do have down pipes. You do have, is there a roof light or is there just something for fan? Or you don't
It's a
have any
vent.
roof lights.
It's a
There's
van.
no skylight over there.
I think
Yeah,
it's
no
not
light.
that. Yeah,
Yeah.
no.
So you don't have any skylights over there, but you have got translucent sheetings over there.
Yeah.
Yeah.
yeah, yeah.
No.
Well done, you
The-
almost finished.
Excuse me,
Yes.
AG, regarding the 6.03, for the, purling and the title patterns, is part of the steel structure? When just wonder what kind of things I need to, measure.
Are you talking about structural steel assignment or this one?
This one, I just wonder because, the purling is steel, so just to
Yeah,
little.
it doesn't matter. It is still part of the roof. Whether it is made of steel or it is made of timber, it is roof, isn't it?
So I
Yes.
just need to calculate how long it is in meter.
Is the whole area for the roofing, you mean?
You need to say that roof component support is having 250 DFC purlins at 300 centers with DB15 Donna bracing and whatever the sacking is there. And then you have to mention the area of roof in meter square. This is the easiest thing because this is
I just
Same
wonder
thing.
how to convert that to square meter.
I think she meant how to make a combined rate.
Yeah, yeah.
That
That
detail
you'll-
element.
that you will get it from your elemental, your Rawlinson over there.
Okay,
Oh.
I will have a check. Thank you.
I'm checking it, so I'm not sure which one gonna use actually. So we have a steel ties for the roofing.
You
covering?
will go and see the steel roofs, basically structural steel roofs.
Why don't you share,
Okay.
it's Chandra, can you share the Rawlinsons?
Yes.
Yes.
So when we're doing the rate, the combined rate, should we do it the way that Ronnie been showing us how to do it from all different elements, all different detailed traits and come into a combined meter?
No, you
Right.
don't have to do. Go and see your element number 6. So 3.6. Go 3.6.
Right, 3.6.
Structural wall.
Yep. So you got your roof coverings over there.
Yeah.
Then you got your, different kind of roof coverings over there. Then you have got concrete tile roofing, or you got, your insulation over there. Go up
Yeah.
over there. Go a little up. So steel roofing. Go down, little down. So steel roofing with wire netting underlay. So you got your sarking and the whole thing covered over there. And you got your sheet roofing, isn't it? So whatever Diamond Tech 300 or what 400 trough, whichever you got, whichever is closest, you take that thing.
All right.
I
Look
think
at
it's
the
a
square meter rates over there.
trapezial profile.
And then you go down,
But that doesn't say purlins, does it?
go down.
Hmm.
Concrete, then finishes to concrete roof decks. Thermal acquisitions, go down. Blankets, eaves cutters, you got over here. Go down. You got your down pipes. No. So you don't have anything about purlins over there. Go up over there. Does it mention anywhere purlins or?
So that is
Yeah, maybe put it in the search, Chandra.
steel.
Yeah.
But
check.
I got it from where it is. Steel section. Frame, under frame, steel.
Yep. So you might get it over there. Check.
Here
So you got
DHS 250. We got it 250, 80. 250. Yeah, that
That's
is
250,
portal.
18.
Portal. Yeah, that is portal knee.
Yeah.
For this one, 250, 18 and 450 UV.
So that gives you the rafter as well as the purlins over there. So
Is
what
there
is the
a
rafter?
rate for less than 10 pitch though? Like that's quite,
So
like that's a
Chandra,
lot more purlin.
your rafter was 410 UB 54, isn't it?
Yeah, it was.
Yeah.
Yeah.
And I think it is happening at 8 meters, not 5 meters, because it's only once happening in one unit.
Yeah, if I go to this one, oh, sorry.
So what I would presume I would go with this thing 410 UB 54 at 8 meter. The cost is 104, and the 410 UB at 5 meter, the cost is 147. But what is happening in your scenario, you got 410 UB and then you got 250 PFC over there at the corner.
Our is 60. Our one is 410 UB 60. So he
Yeah.
still can use it.
Yeah, still use it, you know, still use the same thing.
Hey, RJ,
we
you're talking
need to
about if we're using Rawlinson, we need to use the cost index.
Mm.
Yep.
When can
you-
we have one, or do we have one already?
The indices, basically, you need to know that Rawlinson stopped printing after December 2014.
Yeah, it sounds
So that means the cost which you got over here is for last quarter of December 14.
December. So
then-
the 4 quarters of
And you're doing your assignment in which quarter? Fourth quarter of or third quarter?
22.
well, I think we are in the 4 quarters now.
So if you're doing it in submitting in October, that is the fourth quarter.
Yeah, 4 quarter.
So fourth quarter of
14,
2022,
2014 to
fourth quarter of 2022.
yeah. So we're using the
We use the RLB, the Revit lever or whatever it is, that RLB thing,
yeah to find out the
and
Yep.
cost indices. Yeah.
So
yeah
you-
something that says okay.
You need to understand one thing over here very clearly to make your life easy. If you're calculating from Rawlinson, calculate everything from Rawlinson.
Yeah,
And when you got your total amount done for all the elements put together,
yeah.
then
Then we're using the index.
then you put the indices.
at the
and go
end.
Oh,
Yeah.
at the end.
Yeah, at the end. Yeah.
wow.
Not
Yeah.
for each individual thing.
Yes, yes.
You
that
could
makes
do it that
sense.
way, but you're making
Yeah.
more work. So this has got the roof pitches 10 to 35. Is there a less than 10 degree pitch version? Because that would actually add a lot of steel for like a 35 pitch versus a 4.
See, again, Monique, you need to see what you're getting over here. So what you're getting is on a higher side, which works for you, isn't it? As an estimator, you are estimating a cost without the detailed design.
We don't know the roof gonna be 10
So,
or
so
5.
if you're getting something on a higher side, that is even good for you because you're covering yourself. If it comes a lot less than that, you're saving your money,
Yeah.
at the end of the day.
Ah,
Yeah, and also that's right, we've got a UB 60, not a 54, so that could balance out, I suppose.
Yeah, maybe
Yeah.
just find a closed one,
Yeah, yeah.
You do not know the details. You do not know if it is UB60 over there. So you just taken UB54 over there.
yeah, absolutely right. If it's in the real job, if in the real situation, this is come before we see any of the drawings.
Any of the detailed drawing.
Yeah, any of the detailed drawings. You only have like a concept of things, a design, a space, some height, some width, some length, and some
Yeah, but in
plan.
saying
Yeah.
that, how would we know what steel members then if we're not?
See,
Yeah.
Your
When you say assume, I mean, assuming is quite a long rope.
that is why in your 6035 there's lots of assumption, and your 6035 is spanning from your conceptual drawing to your preliminary drawing to your developed drawings. These are the 3 phases which you will be covering. All right.
Okay.
So what you're doing right now, what you did in your test was your conceptual and preliminary, because you were given only 1 sheet of drawing.
And this is the next stage.
This is the next stage where you've been given 12 sheets of drawing. So it is developed drawing.
Yeah.
So on developed drawing, you can see there are some steel elements happening over there.
Yeah.
Thank you so much, RJ. It's a long
Yeah.
tutorial.
Gonna be here till midnight. Yeah.
All good?
Oh, good. Thank you so much.
All right. So I hope this makes sense. 'Cause I think half of the members are already gone. We've got only 21 left. Including
But
me.
we have clear idea now for actually
The last bet is the main bet.
Yes,
most
this is
important.
actually the main thing for the, for the cost planning, we know. Oh.
Yeah.
We can review it again.
Thank you so much.
No worries. All right. What is
All
the
right, have a
time?
good night.
It's already 10:15.
10:15. Wow. Last time we finished at around 10:40 or something.
Oh, really? We can keep going then.
Last Wednesday, it's all good. So yeah, I hope it makes sense. I have not seen all the questions over there, but I think we have covered most of the things. And yep. So you guys have a good night. Have fun.
Thank you so much, Ajay.
And we'll see you on
Friday.
Friday. Yeah.
Bye.
Bye.
Right. Good night. Can somebody send me that meeting register? Or,
I think it's online, the same Google spreadsheet.
is it?
Yeah.
I will copy. I copy it again. Then you can copy to your.
Yeah, if you can.
I send to you the link.
Yeah, can
think you
send
did.
me this thing because I think it is online.
I don't have the email, but right now I copy paste to the actually the chat box. You can copy it or you can open to have.
Let's see over there.
I think Jenny did it. Can you
Okay.
see
We
from the
got it.
chat box?
Yeah, all good. Thank you. I got it.
Thank you so much.
Thank you guys. Have a good night. Bye.
Bye.